This video is going to show you how you can make some nice box plot using R. And we're going to use base R to do this. There's lots of other stats packages, particularly ggplot2. They can do some really nice fancy plots as well. And I'll make some videos down the line using that. But this is just going to look at some nice simple box plots in base R. As ever, all the data and the code is in the link below this video. The first thing we're going to do is just going to read in our example data called Boxplots and have a quick look at it so I can explain it to you. So this is our data here. What we have here is a score for my students' concern over studying statistics done in the first practical class. So how concerned on a score of 1 to 20 were my students about studying statistics. And then we've got a score on a sort of basic knowledge statistics test as well that they did in the first class, in which they get a score from 1 to 20 in as well. And then we've got this question here, which is whether they have a stats background. So that's basically, have they had any experience doing stats at all? So they've either got no experience, so they've got none, or they have some experience. So this is the data that we're going to be looking at for our box plots. So the first thing is I'm just going to quickly label the categorical variable. So it's the stats background. So that's a factor. It's got two levels. It's coded as 0 or 1. And if they've got a 0, they have none. So they've got no stats background at all. Or if they get a 1, they've got some experience. So we're going to label that as none and experience. And there we go. So we're going to produce some box plots for these sets of scores. Doing box plots in R is incredibly easy to do. In base R, we have our boxplot command. So we just ask for the box plot of the concern variable from my data frame, which I've just called df. So you can just run that. And there we go. He's getting really straightforward box plot. Not particularly inspiring or interesting, but we can see it plots us our box plot. We seem to have one outlier here as well. And then that's just the score and the test on the axis. And again, if we wanted one for the score and the test, we can run that as well. There we go, we get one for score as well. So it's really straightforward, and box plots are really useful because they give you lots of information about the data. You can see an idea of sort of central tendency in the data. You can get an idea of distribution as well, get an idea of outliers, direction of any skew, and so on. So I found them particularly useful. We can plot two variables at once. So in this case, both our variables are scored from 1 to 20. So it's quite straightforward to do that because our axis here, our y-axis, makes sense. So we can plot them side by side. Then we've just got the first one is labeled as 1. The second one is labeled as 2. I'll show you how to edit this in a minute. So we can put them together. Of course, if they're scored on very different things, if this was 1 to 5 and that's 1 to 100, you wouldn't put them in the same graph together because one of them would be incredibly squished down and look stupid and be very hard to understand. So we can only really do that when things are scored on the same scale like this is. Now, I'm going to show you how to do a box plot split by the condition here. So what I'm doing here is I'm asking for the box plot. I'm going to look at score. So we're going to look at concentrate on that variable. Then we've got the tilde symbol. And then we've got our categorical variable. So what this is telling R is I want a box plot for these scores separately for our two statistics background groups. So let's run that. There we go. So because we've labeled our categorical variable already, it says none and experience, it labels our axis. Then we can see what we've done now is split the scores on the test from those who have no experience and those who have experience. And we can see people with stats experience are having better scores on the test. So that's quite a useful table. We can, in a relatively straightforward manner, we can sort of make this look a lot nicer than it does now. There's, It's a bit boring, it's grey, it's in a funny box. The labels are labelled with DF $sign. Obviously, you wouldn't want to put that in a paper or report that you're doing. You'd want to neaten that up a bit. So how can we do that? So I'm going to show you this step by step. So if you want to get rid of the frame, it's exactly the same command, but then we just add the command frame equals false. And if you run that, we drop that frame from the outside, so we can get rid of that if you like. Now we can change the colors. So often this is a good idea. We want to make it look a bit neater. We may want to differentiate the two groups using different colors. So what we can do is col equals and C. So this is our list, and I'm saying dark green in quotation marks here and dark orange. Usually our colors are in for you as well, so you can see exactly what those colors are going to look like. So if you run that, we filled in our colors. If you want to see the range of colors you can use in base art, then here's a link here. So we just go to the graph gallery in colors, and here we go. These are some of the different colors that we can choose. So we could just change a label there. We could say, let's do brown instead. So if I just change dark green to brown, see, it colours it in for us, and we can run that, and then we change that colour. Now, of course, we may want to change our axis labels as well. So it says something proper, not DF, sign stats underscore background. So to do that, we just use these commands. ylab equals, and then in quotation marks, what we want to call it. So our ylab is going to be test score. Our xlab, our x-axis is going to be statistics background. Again, so we can run that. And then we've neatened this bit up here now as well, so we can see we've got nice test scores, nice statistics background. You may want to give it a title as part of this image as well. And more often than not, you'd probably write that in a Word document if you're putting in Word. But just to show you how to do that, we just put main equals, and I'm just going to call it my graph for this example. So main means main title equals, and then quotation marks, my graph. Here we go. So you can have your title and that. So you can see how we've neatened this graph up quite considerably and made it much more palatable for the reader. Now, if we hadn't labeled this axis, so I'm just going to go right back. I'm going to read this data in. So if we run this now, you can see, because I've overwritten it, so I've got rid of the labels that we put in. It says 0 and 1. So if you're in this situation, you could label the axes like the x-axis like this: names equals, and then non quotation marks, comma, experience again. Got C, so that means here's a list. So that's going to label our x-axis in that order. So if you run that now, we've labeled that axis. So we can produce some relatively neat box plots using base R. And you don't have to do it in this step-by-step manner. Really, this does everything in one go. You just need to note between each of these commands I've added, like frame, you need comma after the colors, comma after the lab labels or ylab xlab labels, comma after main, and so on. If you do that, you can get some pretty neat plots together. As I said, this data and the code is linked below this video.